You're watching TelecomTV's exclusive video coverage of the Gen 15 event from Dallas. And I'm joined now by Steve Vogelsang, who is CTO of IP routing and transport at Alcatel-Lucent. Steve, thanks for joining us on TelecomTV.
Thank you.
You gave a keynote here at Gen 15 early this week on network evolution. How are telcos evolving their networks?
Well, I think what they're really trying to do is face the challenge of adding many more devices onto the network, increasing capacity for all those devices and all the services that they're offering. And to respond to that challenge, they're looking for new technologies and really looking to adopt cloud infrastructure, cloud technologies, and remap that into the network infrastructure. And so that's really leading to a few hot trends in the industry. SDN technology, using software to control and manage networks better. Network function virtualization, beginning to move some of those functions, into running on compute infrastructure. And so really talking a bit about where we see those trends evolving and how they're being rolled out into the market.
Now, is optical networking the area that we're going to see a next amount of disaggregation?
Well, there's some discussion about disaggregation in terms of optical line systems, beginning to break those apart. I think the real big trend we're seeing in optical networking right now is a switch to wavelength routing, so dynamic photonic layer, sometimes referred to as CDCF, but the ability to start routing wavelengths across the entire network in a very flexible way. It's necessary to create the sort of programmability that we need in the optical layer to respond to the services and the challenges that operators are facing.
So how does this work and how is this different from what we do today?
Yeah, so CDC technology, which stands for colorless, directionless, and contentionless, what it does is allow you a much better degree of flexibility in how the light is routed through the fiber optical transmission system. Right? Instead of having to worry about which direction it's going, not being able to reuse wavelengths, it's a fully flexible system. So any wavelength from any source port can be routed to any destination port in the network. So you have a truly dynamic layer zero, effectively, photonic layer, onto which we can begin mapping all of the IP technology and building out an IP over optical network.
How far along are we with this? What stage is the work at?
We're now shipping products, full CDC products, CDCF actually, where we can also have variable channel widths, which is the F, flexible. Those products are shipping. I think the next wave we're starting to see is sort of delayering of IP and optical networks and bringing those two layers together to achieve even more efficiencies in how we build and operate networks. And I can talk a little bit more about that if you'd like.
Yeah, please do.
Yeah, so there's a number of things that we're doing to delayer the IP and optical network, and it really starts with the control plane and bringing those two together. So when there's a failure at either layer, it can be detected and indicated. So that means is we no longer have to implement redundancy at both layers, so that gives a pretty significant efficiency gain. I think we estimate something on the order of 40% improvement in overall efficiency. And then the other thing we're doing is using SDN technology to further optimize the network. So through an SDN control layer, you get deep visibility into the current status of the network, really understanding in real time how traffic's flowing across the network, the IP layer and at the optical layer, and we're able to then map services into the infrastructure in a very efficient way and squeeze even more capacity and efficiency out of the infrastructure.
So an optimized network for an operator is going to be one that's cost effective?
It's got to be cost effective. And so that's why we invest in these technologies to put that degree of flexibility, the software control, to extract the efficiencies that allows them to drive down the cost per bit.
When we start talking about virtualizing the functions of a network, virtualizing network functions, what are the main deployment considerations that a telco should be aware of?
Well, I think the big challenge is getting an NFV infrastructure in place. There's a lot of moving parts to get a virtualization layer, to get an orchestration layer, and all that functionality in place, because you have to have that as the baseline before you can start onboarding virtualized network functions. What we're seeing with a lot of telcos is their initial deployments, they'll actually look for a turnkey solution from the vendor where we package all of that up. It's got the VNFs built in, they get an initial deployment. And then they can begin looking at, okay, how do I onboard more VNFs into that environment?
So is that a case of, say, VCPE, which we hear an awful lot of, it's like an early win for telcos?
Yeah, that would be an early example of one of the VNFs that they're looking at, basically bringing the CPE functionality back into the data centers and running it within an NFV environment.
And all this as well, I guess, with existing legacy networks to contend with. It's not just like greenfields, not just replacing and stripping out. You're having to build on top of what you've already got established and invested in.
Absolutely. We'd always love to have a greenfield environment. That's not reality. So yeah, you've got to look at any of these functions and figure out how it ties back into the physical infrastructure. Otherwise, it's really not going to be that valuable.
Final question for you from me. We talk a lot now about open solutions for this industry, whether it's SDN, NFV, but when we say open, what do we mean by open?
Well, it can mean a lot of different things to different people. There's of course open source, which is, as we all know, it's actual code that's available. You can download it, modify it, upstream changes into the code base. I think what we're interested in open, because we really see open as becoming the new de facto standards. It's the open source community that's effectively driving the APIs, interfaces, object models that we're increasingly using to tie together pieces of the infrastructure. So we recently just joined ONOS as an example, which is an open source SDN controller. We did that effectively because we see that as a place where we can bring our knowledge to defining the right infrastructure, the right interfaces, the right object models, and then benefit from the broader open source community and getting it right, and then taking that out to our customers so they have, all have the same type of object models they're working with.
Steve, fascinating. Thanks very much for talking with us today. Thank you.
Great.